Okay, so prior to spring break, we had covered lesson 704, where we talked about how to multiply, or sorry, in this case, how to divide polynomials using an area model. What we do today is going to basically be based on that. So I'm going to do question number 1 with you guys on the warm up, so that it can serve as review, and so that you guys can kind of get an idea of what we're supposed to do. Okay. Please write this down. So whenever we divide polynomials, we will not give you the area model. We'll just give you the equation and then the factor. To make an area model, you need to know the number of columns that you need and the number of rows that you need. And so this right here is showing you how to determine how many columns and how many rows you need. So to determine the number of columns, you need to look at the equation that you are dividing, and whatever the highest power is in that equation, that corresponds to the number of columns. The number of rows correspond to how many terms you have in the factor by which you are dividing by. So for example, if you're dividing by one number, then it's one row. If you're dividing by two numbers, then it's two rows, and so on. Okay? So write this down in your packet so that you can refer back to this for future reference. And I'm going to be using, this right here to kind of base myself on how to make an area model. Okay? All right. So I'm dividing 6x to the fourth minus 5x to the third plus 10x squared minus 18x plus 5 by 3x minus 1. So let's begin by making a big box like this. And now I want to figure out how many columns I need for this area model. I look at my equation. And what is the highest power in the equation? 6x to the fourth, where the highest power is the number 4. Does everyone see that? So that is telling me that I need a total of 4 columns. Remember that columns are vertical. Okay. Rows are horizontal. Now I am dividing by 3x and negative 1. So 3x is considered one term, negative 1 is considered your second term. How many do we have in total? We have 2 terms, so we have 2 rows in this case. All right, so we have a total of 8 boxes, 4 on top, 4 on the bottom. Now let's continue setting this up. So you're going to take your factor, and you're going to write your factor on the side, okay? 3x and negative 1. Like that. 3x and negative 1. And you're going to take your equation, and you're not going to write it on top. You're going to write it underneath the columns, and you're going to kind of go from right to left. I'll show you what I mean. So we start with the 5 right here. And I don't know, can you guys see in the back? Okay. So we'll start with the 5. The next term is an 18x. The next term after that is 10x squared. Then we have a 5x to the third. And then we have 6x to the fourth. Now, if you notice, 6x to the fourth is not underneath a column. Your first term will never be underneath a column. Okay? I'll say that again. Your first term, your leading term, is not going to be underneath a column. Okay, so now that we have this set up, we can go ahead and start solving it. So we're going to go ahead and take the first term, which is 6x to the fourth, and we're going to put it in the top left box. Like that. All right, and that's basically all you need. Everything from here on out is kind of like a chain reaction. You just figure one box, figure the next one. One box, figure the next one, and so on and so forth until you're done. So remember that an area model is multiplication. So we have to determine 3x times what number is going to multiply to 6x to the fourth. Once again, think about 3x times what number multiplies to 6x to the fourth. Sophia. 2x to the third. Very good. So that's going to be 2x to the third. Right? 3 times 2 is 6. X times x to the third is x to the fourth. Now we go underneath 6x to the fourth, and we multiply negative 1 with 2x to the third to give us negative 2x to the third. Okay? You guys all see where I'm getting the negative 2x to the third? Or are there any questions on how I got that? Okay. All right, the next part can be a little tricky, but notice how we are supposed to get a sum, a final answer of negative 5x to the third. So if I have negative 2x to the third, what do I need to combine it with so that I get negative 5x to the third? Negative 3x to the third. So that's telling me that this next one needs to be negative 3x to the third. Right? Because the two yellow boxes have to add up to the one underneath. You guys see that? Okay. And then we start repeating the process again, right? Now you got to figure out 3x times what gets me negative 3x to the third. So think about what multiplication, what product here. Negative x to the second, very good. We multiply negative x to the second and negative 1, and we get positive x squared. And now we have to add positive x squared and some other number to get positive 10x squared. So what are you going to combine with x squared to get 10x squared? What was that? 10. So x squared is already counting as 1. Technically it's a 1. So 9. 9x squared. Okay. How am I supposed to get 9x squared? I multiply 3x with what? With 3x. And then 3x and negative 1, we multiply those together, we get negative 3x. And we have to add up negative 3x and some other number to get negative 18x. So negative 3x plus what gives me negative 18x? And it's a sum. Negative 5 is... Negative 5, what do you mean negative 5? Like the one up here? Okay, yes. So it's negative 5 because when we multiply negative 5 and 3x, we get negative 15x. Negative 15x and negative 3x combine to negative 18x. And then finally, negative 5 and negative 1 multiplies to positive 5. Are we going to have a remainder, or are we good? What do we think? Look at that. The last two blue boxes, are those exactly the same? Yes. So if those two boxes are exactly the same, then that means that you do not have a remainder. And so you're finished. Your job's done. That's it. You don't have to do anything else. If those two boxes don't line up, then you need to add up, or you need to put like an extra value so that you get that final answer. And it could be adding a number, or it could be subtracting a number. But you just want to put the difference so that it adds up to that final box. Now for us, we are finished. The solution will be the statement on top of the columns, which is the equation 2x to the third minus x squared plus 3x minus 5. Okay. And so that right there is the factor that we would need to, or that's the factor that we get when we divide the equation by 3x minus 1. Okay. Great, so I'm going to leave this up here, you guys, and what I would like for you to do is you are going to solve the next one either by yourself or with your team, but you're going to get about the next 6 minutes to take care of this, and then we're going to move on, all right? So go ahead and get started on number 2 using the same method that we just did for number 1, okay? All right, so I'm going to require your help on how to like set this up. So I'm going to pretend that I don't know what I'm doing, and I'm just going to start by making a giant box. What should I do next? Raising your hand. How many columns do I need? Gio? 3. How many rows do I need? Jason? 2. All right. Where should I put the terms 2x and negative 3? Go ahead. on the left side. 2x and negative 3. And then where does the equation go? On the top? Bottom. Okay. So I'm going to go 18, 2x, 17x squared, and then 6x to the third. All right, let's begin. So we have 6x to the third on the inside top left box. What goes on top of that column? 2x times what gets you 6x to the third? 3x squared. 3x squared. So if I have 3x squared there, then what do I have in the bottom box? Negative 9x squared. Now the sum of negative 9 and some other number have to add up to negative 17. So what is my other number? Negative 8x squared. How do I get negative 8x squared? Negative 4x on the top. So then I get positive 12x down here. The multiplication between 12x, the sum of 12x and some other number have to add up to positive 2x. So we're going to be subtracting. What are we subtracting? Negative 10. And how do I get negative 10? What do I multiply? Negative 5 with what? With 2x. And so that'll give me positive 15. Now here is a slight problem, small problem. And the problem is what? What can you tell me the problem is, Sophia? It's not the same. 15 and 18 are not the same. So how do I get 15 to equal 18? You carry a 3, you add a 3. This plus 3 is considered your remainder. Okay? So this extra number that we need to be able to get to 18 will be a remainder. Now, when you write your remainder, there's like a special way of writing it in your final solution. So please pay attention to how I write this down. So our answer is the following. 3x squared minus 4x minus 5. And then your remainder will be written as a fraction. The numerator corresponds to the remainder. The denominator corresponds to the original factor, the one that you were dividing by in the beginning. We were dividing by 2x minus 3. So we're going to get the statement 3 over 2x minus 3. Okay? Yes, question. What do you mean? Uh-huh. It could happen, but we won't see that in this class. All the polynomial division that we see in this class will be dividing by 2 terms. All right. Any questions then on this section? All right. So I know we took our time with the warm up. That's fine. I'd rather take things kind of slow. Make sure you guys understand. So what we just did, we're gonna actually repeat in the lesson today. And the lesson's kind of short, but let's take a look at some guided notes and see what we can come up with. All right. So. So it says the following. The division in problem 1 is special because there is no remainder. This tells us some important things. The first thing that it tells us is that 3x minus 1 is considered a factor. So write this in. 3x minus 1 is considered a factor of the function 6x to the fourth minus 5x to the third plus 10x squared minus 18x plus 5. Now think about what it means for something to be a factor. I'm going to use some very simple numbers and you're going to tell me whether or not it is a factor. Ready? Okay, think of the number 2. Is the number 2 a factor of 6? Yes. Okay. Those of you guys that are saying yes, tell me why. Why is 2 a factor of 6? Be more specific. 2 goes into 6 3 times. Do we have a remainder? No. 2 goes into 6 evenly, and 3 times, right? Let me give you another number. Is 4 a factor of 8? Yes. Why? It goes in twice with no remainder. Is 5 a factor of 8? No. Why not? It goes into 8 once, and then we have a remainder of 3. Do you guys see what I'm saying? For something to be considered a factor, there must be no what? Remainder. So we're going to apply that to our polynomial division. When you divide by a polynomial, if you have a remainder, then it is not a factor. If you don't have a remainder, it is a factor. So in this case, because we don't have a remainder in problem 1, then 3x minus 1, which is what we divided by, is considered a factor. There are 3 representations of a factor. It's not there anymore. So let me write it here on the side. So I want you guys to, you don't have to write this down, but just follow along. So there's 3 things, right? So you'll see something that's called a factor. You'll see something known as a root, and then you'll see something known as an x-intercept. And these 3 are the same thing. They represent a point in the graph where x is equal, or when y is equal to 0. Okay. Now, let's say we use the factor from problem 1. The factor in problem 1 was 3x minus 1. To determine the root from 3x minus 1, what we would need to do is we would need to set this equal to 0, set the statement equal to 0, and solve for x, which would give us x equals 1/3. As an x-intercept, 1/3 would be written like this, 1/3, 0. However, all 3 of these are exactly the same thing. They represent the same thing. An x-intercept is the same as a root. A root is the same as a factor. They are the same exact thing. And now the reason why I'm going over this is because in the notes, I'm going to talk about a factor, a root, and an x-intercept, and you'll see what I mean. So look at this. We said 3x minus 1 is a factor because there's no remainder. 1/3 would therefore be a root because 1/3 we derive from the factor 3x minus 1. Well, if 1/3 is the root as an x-intercept, we could write that as a point 1/3, 0. And so that is where I'm getting these values from. I'm not coming with these values like from thin air. I'm not coming up with them from thin air. I'm getting them from the representations of a factor, a root, and an x-intercept. All right? So that's where that is coming from. Okay. Any questions so far? What I really want to drive home right now is this idea that for something to be considered a factor, there must be no remainder. Okay, because that's what we're going to be determining in the next few examples. So let's flip the page and look at example number 1 together. All right. Example number 1 says the following. Determine whether 3x plus 5 is a factor of the function y equals 3x to the third plus 11x squared plus 7x minus 2. If so, find all the roots of the function. So right now what we're trying to figure out is, does the function 3x plus 5 fit into the function y equals with no remainder? What that's essentially telling you to do is, hey, you're going to do this polynomial division, and you're going to find out whether or not there is a remainder. That's what we're being asked to do. So we're going to begin by setting up our area model. Start with the giant box. And how many columns will I need for this box? 3 columns. How many rows will I need for this box? 2 rows. All right. What am I going to write on the side? 3x plus 5. And then the equation will be written down here. So negative 2, 7x, 11x squared, 3x to the third. All right. Are you guys ready to solve this? All right. So we'll begin with 3x to the third in the top left box. I'll take volunteers, so just if you have something to give me, please raise your hand, and then you can give us your input. What goes on top of 3x to the third? Go ahead. X squared. What goes next? Josiah? 5x squared. Good. All right. And then what? What's next? Go ahead. 6x squared. 6x squared here. So that it adds up to 11x squared. If there's a 6x squared there, then what goes on top of 6x squared? 2x. So what goes underneath 6x squared? Not quite. It's the product of 5 and 2x. Let me hear from Michaela. What's 5 times 2x? What is it? 10. 10x. Okay. How would I get 10x to equal 7x? Let me hear from people who I haven't heard from yet. Kevin. Negative 1 would get us 9x. So not negative 1. To go from 10 to 7. Ella. Negative 3x. How will I get negative 3x? I multiplied 3x and what? Negative, what was that? Negative 1. Negative 1. Negative 1 and positive 5 adds up to, or multiplies to negative 5. What do you notice? There's a remainder of 3. So, here's the big question. Is 3x plus 5 a factor? No, why not? Because there's a remainder of 3. So you're going to write that statement down. 3x plus 5 is not a factor because there is a remainder of 3. Okay. You have to justify your answer. So you can't just say, no, it's not a factor, period. You have to tell me why. It's not a factor because there's a remainder of blank. Make sense? Okay. The cool thing is, if it is not a factor, you just say it's not a factor because so-and-so, and that's it. You don't have to do anything else. If it is a factor, you have to do a few extra steps, and that's what I'm going to show you in the next section. Okay? All right. Any questions so far on example number 1? Specifically, how we got the area model? It's really important you guys understand the area model. If you don't understand the area model, then obviously you can't determine whether something's a factor or not, right? It's like running before walking. You have to know one thing to know the other. Okay, let's move on to example number 2. Determine whether the point 3, 0 is an x-intercept of the function y equals so and so and so. All right. So this is an x-intercept. I don't want it as an x-intercept. I need this to be a factor. So I'm going to go from x-intercept form to root form. And then from root form to factor form. Okay. Think about how I showed you that these are the same. 3 comma 0 is an x-intercept. If 3 comma 0 is an x-intercept, then what is the root? It's just a number. What's the number? 3. So 3 comma 0 is an x-intercept. That means 3 is a root. So what would the factor be then? We would have x, 3 equal to 0. Would I need to add 3 or subtract 3 in this equation? I would need to subtract. It's the opposite. So x minus 3 equals 0. So x minus 3 is a factor. Okay. All right, let's go ahead and set up our box. 3 columns, 2 rows. All right, I'm going to go through this one a little bit faster since you guys are starting to understand this. So let's see, x times x squared is going to give you x to the third. That'll give you negative 3x squared down here. Negative 3x and 2x squared will get you negative x squared. So that'll be 2x up here. Negative 3 and 2x multiplies to negative 6x. So I'll need negative 8x down here, or up there, I guess. So that'll be negative 8. Negative 8 and negative 3 multiplies to 24. All right. What do we notice about this problem? Do we have a remainder? Tell me. Look at the boxes. No, we don't have a remainder. So we can say that x minus 3 is a what? A factor. We could also say that 3 is a root. And ultimately that the point 3 comma 0 is an x-intercept, right? If something's a factor, then it's a root, then it's an x-intercept. Anyway, so this is what you have to do next. Ready? So you do have to do some extra steps. This factor, x squared plus 2x minus 8, we now have to take this and we have to set this equal to 0. Because we need to solve for all values of x. The cool thing is that's a trinomial, which we can factor with the giant x. So we can just look for two numbers that multiply to negative 8 and that's a 2. Four and 2, which one's positive, which one's negative? 4 is positive, 2 is negative. All right, so we have 4 and negative 2. That means we have x plus 4 times x minus 2 equals 0. And if we solve each of these, we get x equals negative 4 and x equals positive 2. All right, so we have solved for all values of x. We just have to do the one final thing, and this is what you must do at the end. Oh, knocked my water over. You're going to write the statement roots like this, followed by these like curly brackets. And inside these curly brackets, you will write all of the roots that we found. So the first thing was we found that x minus 3 is a factor. So that means that 3 is a root. And then from solving the trinomial, we found two additional roots, which were the points 2 and -4. So in total, we have those three roots. The roots in this problem are 3, +2, and -4. Okay. All right, and so now we're done. Okay. All right, we have one final example, and then we'll get you guys your break. Ready? Let's do it. Determine whether 3 is a root of the function y equals so and so. Well, 3 is in root form. I want it in factor form. So what is 3 in factor form? Is it x plus 3? It's minus 3, right? X minus 3. Let's set up our boxes. 3 columns, 2 rows. We are dividing by x minus 3. And we're dividing the following. We're dividing x to the third minus 3x squared plus 8x minus 24. Let's fit in x to the third in the top left. And let's figure out what needs to go on top. X times what? X squared. That'll give me negative 3x squared. What do I need to combine with the negative 3x squared so that it stays as negative 3x squared? 0. To get 0, that means I'm multiplying by 0. Sorry? Well, only that column is equal to 0. So x times 0 is 0. Negative 3 times 0 is 0. So if that, what am I missing? The sum of 0 and what number is going to give me 8x. So what am I missing? 8x. I'm missing 8x. So to get that, I have an 8 plus 8 on top. And then 8 and negative 3 makes negative 24. And if you look at that, do we have a remainder? No. So is this a factor? Yes. Amazing. You guys are getting that. Since it's a factor, we have to do a few extra steps. So let's take this statement, x squared plus 8, and let's set it equal to 0 so that we can solve for x. How would I algebraically solve for x? Think about StatMap. Subtract 8, and then square root it. Good. So subtract 8. We have x squared equals negative 8. To cancel the square, we square root. So x equals plus or minus the square root of negative 8. And if this were any other class that is not IM3, we'd probably stop there. But this is IM3, and we've shown you in 701 how to simplify radicals. So we must simplify negative 8. So let's begin by addressing the initial problem with negative 8. We can't take the square root of a negative. We have to take the negative out. So we're going to go ahead and factor this out. We'll take out the negative 1, and that'll leave us with positive 8. Now let's talk about the factors of 8. What two numbers multiply to 8? 2 and 4. So we're going to split up 8 into the product of 2 and 4. And now let's reduce each one. What is the square root of negative 1? We've talked about this imaginary number. I. So this will become I. Can I do anything with radical 2? Can I take the square root of 2? No, because it's not a perfect square. Can I take the square root of 4? Yes, it is a perfect square. The square root of 4 is 2. Let's put this together. So we're going to get the following. X equals plus and minus 2I radical 2. I hope you still have space on your paper because we have to write our statement roots. So I'll go ahead and do that here on the side. Nice and big for everyone to see. So the roots in this question are 3 and then plus and minus 2I radical 2. Okay. All right. So you will not get full credit unless you write that statement roots. Okay. You need to write the statement roots and then put the roots in there. All right. Any questions so far? How are we feeling? Ready for our break? Okay, let's take our break. 15 minutes. I want everyone back here at 9:40. 9:40. What's up?